Hello and welcome to my channel. My name's Ian and I'm reading some stories from 50 odd years ago. So you got something different to watch. That is true to form from that age. Today this one's called Mystery of the Black Holes and it's a really old story. So I'll start now. Imagine a star made of matter so dense that enough to go into a matchbox would weigh 10,000 million tons. If a rocket is to escape from Earth's gravity, it needs to reach a speed of about 25,000 miles per hour, but the gravity of this star would be so enormous that there would be no escaping from it, even at 670 million miles per hour, about the speed of light. Indeed, light itself would not be able to escape, making the star forever invisible. Such stars are believed to exist in the universe, as light cannot leave them. No one has ever seen one, but astronomers have good reasons to suppose they are there. They are called black holes. One of the first clues to their existence came from the odd behaviour of a star called Epsilon Aurigae, a giant 60,000 times as bright as the sun. Once every 27 years this star fades to less than half its usual brilliance. Scientists know that Epsilon Aurigae has a partner which swings with it round a common centre of gravity. The fading was presumably caused by the partner getting in the way of the view from Earth. But why in this case does the partner emit neither light rays nor radio waves like other stars? The answer seems to be that the partner is a black hole, invisible, small but enormously heavy. Scientists are able to explain how a black hole could be created. The heat of stars like the, the heat of stars like the sun come from continuous nuclear fusion, the process that goes on in the hydrogen bomb after thousands of millions of years. The store of nuclear fuel in the star begins to be exhausted. Then the star cools down and eventually implodes, that is, collapses inwards in a matter of seconds with terrible violence. The sun will do this in about 8,000 million years. It will end up as a small cool object called a white dwarf. But the forces of gravity in stars 1.5 times the size of the sun are much stronger. When they implode, they squeeze smaller than white dwarfs until the centre becomes so hot that it explodes outwards. The exceptionally bright mass which results is known as supernova. When this happens, a tiny part of the star remains at the centre, fantastically compressed by gravity. This is known as a neutron star. But there are much larger stars, some as much as 50 times the size of the sun. When one of these collapses, it will contract even smaller than the neutron star. If it is only 2/3 the size of a neutron star, the gravitational pull would be so strong that nothing could withstand it. Not even light could escape, and even if the star was white hot, nothing could be seen. For this reason the phenomenon is called a black hole. Compared with the vastness of other objects in the universe, black holes are tiny. For example, a collapsed star 10 times bigger than the sun would be compressed into a black hole less than 40 miles across. Because they emit neither light nor radio waves, astronomers can only speculate about their presence by the behaviour of neighbours under their influence. Having so enormous a force of gravity, black holes suck into themselves any matter that comes into their part of the heavens. One theory even has it that they will eventually suck up everything in the entire universe. Meanwhile, they are busy absorbing part of their neighbours. One supergiant star in the Cygnus constellation, called HGE 226868, which is believed to be paired with a black hole, seems to be losing clouds of swirling gas into its invisible neighbour. Once it gets closer to the black hole, the gas becomes invisible, entering what is called the event horizon. There is a limit to the pull even of a black hole gravity, and there must come a point where light can neither escape nor be pulled back. On this event horizon, light would stand still or move very slowly. This raises the fascinating possibility that light images on the event horizon would go on being seen for more or less forever. For instance, if an astronaut headed for a black hole, he might still be seen going through the event horizon for millions of years afterwards. However, the prospects of any man landing on a black hole are small indeed. Closing in on the event horizon, those parts of the spacecraft or his body nearer to the black hole would receive more pull than the gravity. The results would be to stretch him out into a streak miles long, whilst the compression reduced his volume. If the spaceman was able to observe a clock far away from the black hole, the hands would appear to move faster as he approached the event horizon, until he was unable to see them. As he went through the event horizon, the hands would reverse, start slowing down, and he would appear to be going backwards in time, though the time as measured by a watch on his wrist would not change. Once through the event horizon, the spaceman would be unable to escape. In fact, the harder he tried to avoid his fate, the faster he would meet it, since the energy expended in the attempt would produce increased mass and hence increased gravitational attraction. As the spaceman approached closer to the black hole, he and his spacecraft would be torn to shreds by the tremendous force of gravity long before touchdown in a small black hole, say one of twice the sun's mass. It would take only 20 millionths of a second for him to fall to the centre. In fact, for the experience to have any noticeable duration, the black hole would have to be very large, even in 1,000,000 times the size of the sun. The falling process would take a maximum of only 10 seconds. One mind-boggling theory is that if a man ever did enter a black hole and avoid destruction, he might find himself in another universe, travelling backwards in time. This idea is based on the way which a black hole appears to behave, like the rest of the universe, only in reverse. For while the universe is continually exploding outwards, a black hole is forever imploding or turning in on itself. And while science can explain matter compressed into an astonishingly dense pinprick, it cannot account for matter disappearing absolutely. Thus, as the universe represents a process of seemingly endless outward expansion, so the black hole represents inward expansion without a foreseeable limit. It has been suggested that a black hole may exist in our own galaxy of stars, and some scientists even think that there may be a little one in the middle of the sun, and that this is affecting the sun's production of certain kinds of radiation. According to some theories, man could use a black hole to produce energy for his own purposes by directing matter towards it and storing the gravitational energy sent out by the black hole as it sucks the matter in. It will thus be used as a sort of cosmic garbage can, giving out energy for any unwanted rubbish thrown in. Still, other scientists dispute the very existence of black holes. Only one thing is certain: black holes are one of the most intriguing concepts to come to man's attention this century, and they are going to occupy the thoughts of astronomers for years to come. And that was a story about black holes, and I hope you enjoyed that one. If you don't mind, please could you like and subscribe to my channel, and I'll keep bringing out some new stuff, some old stuff from years ago for as long as I can. Anyway, thanks for watching. Thank you.